What is thermal comfort? Early settlement began in mild climates. As man moved north, he had to develop different kinds of shelter to be comfortable through the changing seasons. The building environment, which acts as a filter between the inside and the outside, gradually became more sophisticated. During the 20th century, we gained unprecedented control over our thermal environment, mainly thanks to energy-consuming equipment such as central heating systems. As we advance into the 21st century, world population, the percentage of urbanized areas, and expectations of comfort and well-being continue to grow. Striving to reduce energy demand of buildings while providing comfort and well-being requirements is more important than ever. Designing efficient building envelopes is one of the first steps to consider. Today, we spend more and more time indoors, where we expect a level of thermal comfort that ensures comfort and well-being, but can be provided efficiently. While extremes in temperature can be fatal, even gentle fluctuations can cause us increased pleasure or discomfort. Concentration, manual dexterity, and instances of accidents can be influenced by both high and low temperatures. The basic principles behind thermal comfort are largely universal, but thermal comfort varies from one person to another. The physiological aspect of thermal comfort. Human bodies, as with all mammals, are thermal engines that generate and dissipate energy. We have different ways to balance our constant heat exchange with the environment. For example, by shivering, perspiring, or modifying our blood flow to regulate heat distribution. The objective of our metabolism is to regulate our body temperature with minimal effort, if possible. So we need to be able to control the physical environment surrounding us. The physical aspect of thermal comfort. Thermal energy, heat or cold, can be transferred by three means which influence our perception of the environment. 1. Conduction is energy transferred via a solid, for instance by touching a surface. 2. Convection is energy transferred from a solid to an adjacent gas or liquid. 3. Radiation is energy emitted from a surface. An overall balanced thermal environment is key to feeling comfortable. But our bodies are very sensitive, and local variations within our environment can cause great discomfort. For example, sitting too close to the fire, or by an open window on a cold, windy day. The socio-psychological aspect of thermal comfort. Many other factors influence our perception of our thermal environment. Our current emotional state, mood, or how tired we feel. Our thermal programming and social background. As well as other environmental factors such as noise or glare, which can make us agitated and feel hot. Our perception of heat also depends on varying tolerance levels. For instance, the more control we have over our thermal environment, the better we feel and the more productive we are, whether or not we choose to use this control. Designing for thermal comfort. There is no one-size-fits-all recipe for thermal comfort. Solutions vary depending on the local climate, as well as the type of activity performed by the building users. The building envelope acts as a filter between the exterior and interior climates. Designing it efficiently implies the consideration of 5 main factors. 1. Insulation reduces heat loss during cold seasons and heat gain during warm seasons. 2. Solar gain is influenced by the building's insulation levels, its shape and orientation, the window to opaque wall surface ratio, the type of glazing, shade or shading devices. 3. Thermal inertia varies according to the mass and material of a building. High inertia envelopes give more internal temperatures in the face of outdoor temperature change. 4. Airtightness and ventilation enable the control of air exchanges with the outside. A well-designed building envelope can dramatically reduce the need for mechanical systems required to provide thermal comfort, so reducing the environmental impact. The future. Although our basic thermal comfort requirements are likely to remain the same in the future, our outdoor environment is likely to change further. Climate change will play an increasingly important role in the design of the built environment. New systems and materials will continue to be developed and refined. These changes, as well as a new approach to energy use, will require buildings to be capable of evolving over time in order to be both comfortable and energy efficient. A key factor in this evolution will be to ask ourselves what levels of thermal comfort will be considered acceptable. Should we just put on a jacket rather than turn up the heat?